The topic is building a web attacker dashboard with ModSecurity and BeEF. Ryan Barnett is renowned in the web application security industry for his unique expertise. After a decade of experience defending government and commercial websites, Ryan joined TrustWave's Spider Labs research team. He specializes in application defense research and leads the open source ModSecurity web application firewall project. I'd like to thank everybody, Ryan Barnett, for coming.
All right, thank you, everybody. Welcome. This is an interesting topic. At least I think when I was putting these pieces together, I said this could be really useful. So, jumping ahead here, just to give you a little more background on what I do at TrustWave. I'm on the Spider Labs research team. We do a lot of different services where we back up the front-end Spider Labs guys who do the app pen test, network pen test, forensics, that stuff. My focus is on web application defense research. Mainly, I'm helping with the web app firewalls. So commercially, we have WebDefend. But specifically here, what we're going to talk about is the open source option, which is ModSecurity, specifically because it has some really cool advanced features that allows the integration that we're going to talk about. At OWASP, I do lead the ModSecurity core rule set, which is a set of rules that help you to quickly secure your website from a lot of these attacks. I'm also a contributor to the AppSecUSA project. So how many people have heard of AppSecUSA? Are you familiar with it? More OWASP people too? So AppSecUSA is actually relevant. A couple of the different scenarios we're going to talk about, categories, is very related to AppSecUSA when we talk about detection points and then different response capabilities. Then also have the shameless plug for my book that's coming up. It's not out yet. I tried to get the book here in time for the bookstore and all that fun stuff, but it's not coming out till December. But I do have some information about the book. There's like author signing and stuff. So if you have any questions related to that, just come see me offline. But this is also relevant because what I talk about here is actually in the book. That's where I kind of came up with this idea. So who is the audience? So hopefully, we'll be talking about you here. Hopefully you're in the right spot and this is the right topic for you. From OWASP perspective, if you're familiar with the communities, I'm not really sure the timeline a year or so ago when this really came up. The idea was if you went to OWASP, there was so much information, so many different projects, that you really weren't quite sure based on what your job is, day in and day out, where do I go to find the resources that are applicable to me and what I do and what I'm responsible for. So that was the idea in a generic sense of why they came up with the idea of communities. So the three different ones obviously are the builders. So if you are a developer, you're part of the builder community. There's a bunch of different ways you can identify the projects related to you. Then you have the breakers. Those are the app pen test folks, right? Finding all the holes, finding out where there's vulnerabilities, talking with the builders about fixing them. So what we're talking about today is defender community. So that's operational security. So we are not in charge of building the apps, necessarily finding vulns, although we can find certain things in production. We're in charge of preventing attacks. When live attackers are attacking your live website, it's on us to try and prevent that. Okay, so just getting some good scope here. I also liked tying in the defender community, making sure everybody fully understands where does that fit in the whole SDLC. So builders and breakers obviously have different points along here on the SDLC touch points. Right? When you're building an app from scratch, you go through all these phases. So defender community, we're on the far right, right? So once it's in the field and it's live, that's where we live. Okay? Now we can work with the other groups because there's lots of intelligence that we identify that we can feed back to other groups to help them improve things. But just I want to make sure everybody's aware of the context of what we're talking about today. All right, so the agenda breakdown. What are we going to talk about in the next odd 40 minutes? So the web application security risks, making sure you understand that kind of process flow and what we're targeting here, why it's different than what most defenders have been doing. Situational awareness, that's kind of the big key, is understanding who your threat is, where are they interacting with your site, and then tracking them. That's the key that I think has been missing from a defender perspective. We're doing way too much whack-a-mole against individual attacks. As somebody sends an SQL injection, you blocked it. Yay! You did nothing to stop the threat, right? You stopped that one bullet that came at you. So trying to target more at the threat itself. So then we get into building this dashboard. Now keep in mind, this is total proof of concept, right? We kind of cobbled these pieces together, but I wanted to give you an idea. We do have screenshots of what it looks like in BeEF with this whole integration. I want to get you thinking. I would love feedback. Also, from a developer perspective, there's some integrations that we did. We'd love to extend this and get more use case scenarios. So I have some that I'll present to you, but I'm sure there's lots of other cool ideas that you'll have. So we're showing the 3 different components really that we're putting together, which is ModSecurity BeEF and then the ModSecurity Audit console. And then usage scenarios, and then we'll kind of close it up. All right, so if you've looked at the OWASP top 10, this probably looks familiar, right? Talking about the risks. So looking here, you have all these different categories of what are the threats to your site here. So on the far left, you have the threat. They may launch a variety of different attacks that'll take advantage of weaknesses in your application. If you're missing certain security controls, then you have an impact. It could be a technical impact or a business impact. I mean, you look at this graphic, it all makes sense. So I wanted to take this graphic that we're all kind of familiar with and makes sense and to point out why there's a problem here. Where's the gap? Okay, so that's my main issue. So I'm a defender, protecting the website. Let's say I'm using ModSecurity. I have the core rule set. I'm blocking SQL injection, blocking cross-site scripting, doing these types of things. The problem is I'm focused on stopping the individual attacks. That's the whole whack-a-mole. Okay, what we're not doing is focusing on the threat. Okay, so let's shift our focus, keep this in mind as we're moving forward. So situational awareness, I love this picture because I think it's very relevant. And back, if you can't see it very well, obviously you have the big, huge shark in the background. So why I think this is important is if you take the analogy that this is like your average website owner, the scuba divers, we're selling our widgets. Everything's cool. And meanwhile, they have no idea the threat that's right in back of them. Right? They don't see it. It's having an understanding of where your threat is, in this case, behind you, and knowing what to do about it. So I wanted to combine my web application defense passion with my other passion, which is watching Shark Week, if anybody likes watching that on Discovery Channel. So let's do a quick analogy here of walking through this whole process. So our threat agent in this case, great white shark, what attack are we looking to defend against? Sharks. What attack? Yeah. Yes, right? The attack. So what's the security control? Got it. The cage. Right? So we're looking through. We know what our threat is. We know what attack they're going to do against us. Let's put up a control. But we're still back to the same problem. Right? We're stopping the bite from them attacking us, but are we doing anything to know, should I actually get out of the boat in the water and do my snorkeling? Are there any sharks around? I don't know. Do I need a cage? I don't know. So again, we're back to this of you got to track the threat. Let's focus back on the threat. So looking at threat agents, 3 general categories that I think the industry, when I was looking into this and doing some different discussions, can put them in some different buckets, right? So the first one is random opportunistic. So again, sticking with the shark theme. You're out there swimming. You decide I'm going to go surfing. From the shark's perspective, they're hungry. They're looking for something to eat. They're looking up at you. It may be a mistake, right? Looking here on the far left, the surfer looks an awful lot like the sea turtle and the sea lion. So they may bite you, and you see that on the news all the time when surfers get bitten, and it was a mistake, right? The shark bit them and realized this is not what I wanted, and they let go, but the damage is done. The next one is directed opportunistic. In this case, they're hungry. Ooh, look at that crowded beach. Right? All those people in there, lots of food. I'm going to go get something to eat. And the third one would be if you're doing Jaws versus Sheriff Brody. Right? That is a targeted attack. Right? Jaws wanted him. So knowing the 3 different contexts here of what we're talking about from your threat, there's different reasons why somebody may attack your site. It's important to understand why are they doing this. Are they targeting you specifically? So this is what I thought was missing from tracking the attackers. It's being able to do this kind of satellite tracking, right? When you see that again, love the old Shark Week, when they tag them, send them out, then they monitor them. So imagining this on the right-hand side, if you're putting this in a web security perspective, if you can tag the attacker, and then imagine on the right, the map here, instead of the Gulf of Mexico and tracking this whale shark, the movements, that's a visualization of your website and where they're going and what they're doing. That would be really cool to have, because we don't have that today, right? We can see, oh, there was 500 SQL injections we blocked. Yay. Okay, but we don't really have any context about where the bad guys are. So taking that analogy, let's go back to the web application security focus. And we still have those same three categories, right? Random opportunistic. Looking there, I can speak from my own personal experience. All the different types of attacks that happen against, especially WordPress sites, things like that, where the bad guys don't care anything about you. They just know, oh, look in bug track. There's a new WordPress vulnerability, and in this case, Tim Thumb. You mean I can inject code in there and download an RFI payload and get a web shell and do whatever I want? Cool. They don't care what your website does, what your business is, what your users are. They want to get that level of access so then they can put malware links and stuff like that. Okay? But in this case, keep in mind, they don't care who you are. They're looking for vulns, whoever has them, they're trying to break in. The other thing to think about is a lot of these random opportunistic attacks, they're not done by real users, attackers in web browsers. Right? It's botnet stuff. It's a lot of scripts that are being done. So that plays into the context if we try later on to hook them with BeEF. Those aren't necessarily the candidates we're looking for because they don't run JavaScript. It's not a real web browser. Okay? Directed opportunistic, that would be something, if you remember, the whole WikiLeaks and all that kind of stuff where certain organizations got hit because there was an impact of what they were associated with, why they were targeted. And then fully targeted, of course, different operations saying, let's go, in this case, let's go hit Sony. They have all these people trying to figure out how to break in and compromise that specific target. All right. So talking about attacker methodology, this is some lessons learned, and this may ring bells with anybody in here that does the operational security. A typical kind of standard operating procedure that we see, if you're getting not the random opportunistic, but getting more targeted, is the bad guys will use automation. They use automation to see if you're vulnerable, if there's some injection points that they can take advantage of. So what I'm showing here was some data that we gathered, public data, which is why I'm referencing this. We did the ModSecurity SQL injection challenge, where we challenged the community to bypass our blacklist filters to see if they could do a filter evasion. So then we went back, because we had all the logs, to identify how they do what they did. So usually they use automation, use tools like SQL Map, Arachne, Havij, all these different tools to say, this certain page, this certain parameter, it's vulnerable to SQL injection. That gets the attacker halfway there. Now they know where they need to target their analysis on. But then typically what they will do is manually try and figure out how can I manipulate this, how can I do an evasion. So at some point, the targeted attacker, the directed attack, is going to be a real person in a web browser. So again, put in context of what we're looking at here. So now, that same analogy we had with the shark earlier, let's change our focus. Instead of doing whack-a-mole against individual SQL injection, let's figure out how to target the individual attacker themselves. All right, so this is the big question. And I've asked this to several people, different customers we have, different users. That's really what we're talking about here. Can you track malicious users on your website? And sometimes you get different responses. They'll say, oh, yeah, I can track them. You know, we're blocking, like I said, 50 SQL injections. I said, well, that's not what we're talking about. You're talking about the symptom, the attack, not the cause, the attacker. Then they think about it. Then the typical next response is, oh, yes, because we identify malicious IPs based on the attacks that we see. And the question is an IP address a user of your application? And you see the wheels turning. You're like, not necessarily, right? Because of open proxies, legitimate reasons why people may not be coming from their home system. From a bad guy's perspective, things like Tor, all that kind of stuff, they want to hide where they're coming from. So an IP address is not what we're talking about. We want to try and get to the end user, go a step further, trace back. All right, so this is what brought me to this idea of saying, okay, we somehow have to get in the browser. How can we do this? Now, I had played around a bit with doing some things with ModSecurity itself. There's some injection capabilities we'll talk about here in a second. But that's where it was up to me to say, what kind of JavaScript do I want to write to achieve X, Y, and Z? And I'm like, this is manual. It's a pain. Writing JavaScript is not my forte, what I do every day. So there's got to be a better way. And that's when I talked with my colleague, Michele, and said, hey, wait a minute. That's what BeEF does. BeEF is used to hook clients, send code down into the browser, and do all sorts of things. So I'm like, why reinvent the wheel? Let's figure out how to put these things together. Okay, so for those who aren't familiar with BeEF, okay, this is not a BeEF tutorial. I'm by no means qualified to give you the ins and outs. Michele is actually talking later today. The info is down here at the bottom of the slide. So if you have specific BeEF questions, what it can do or anything code level, he's your man. I think it's at 3 o'clock, is that right? Yep, 3 o'clock. So go find him. Now, BeEF is typically used under some type of network pen test or something like that by penetration testers to show to an organization the susceptibility of their internal users and the problems they can cause, right? So if you can hook a legitimate internal web user, then you're inside the network, you can do all sorts of bad stuff. Okay, so that was the use case, right? You're a bad guy, you need to hook an innocent, benign user, and then you're doing stuff internal to the network. So take that whole concept, though, and flip it around. Now we're talking about, let's have the good guys use BeEF to hook malicious users and do some enumeration and different things. So it's using the same tool, but using it in a different purpose. So one of the big issues from BeEF's perspective in using it is actually how do you initially hook a client, whoever it may be. So there's lots of different ways you can do that. You can do some of it through phishing and send people emails and things like that. But a typical one they'll try and do is look at a website that their target user is using and look for a cross-site scripting vulnerability. And in this case, something like a stored cross-site scripting issue. So you can see down here what I tried to highlight. In this case, it's WordPress, just doing like a blog forum post or something like that. You put in some JavaScript, and the highlighted section is what's relevant. What that does is it points the user's browser to the BeEF hook. That's the initial JavaScript that gets in the browser that sets everything up. And it sets up the communication channel back with BeEF. So under normal usage, that's one of the challenges, right? The person who wants to install or hook a client with BeEF, they got to figure out how do I hook them. Now, once they're hooked, you have this whole interesting process flow, communication channel back and forth. So starting up at the top, that's what we just showed, the initial hook. Let's say it was cross-site scripting. Now it's in the client's browser. What ends up happening is you have a BeEF server, some server that's ready to give the initial hook and also receive communication channels from a hooked client. And there's different polling mechanisms that they do using XML requests. And now also there's stuff with WebSockets. There's stuff where it's a lot faster. But essentially your client, once they're hooked, they're constantly polling. They're polling the BeEF server to say, hey, do you have anything you want me to do locally here in the client's browser? And then it's up to you as the BeEF admin to say, oh, OK, I see I have a hooked client here. What do I want to do? I want to find out what plugins they have. Go. And then when the client polls and says, oh, there's a new job, they want to know what plugins, it runs it, and it reports it back. So it's this constant communication flow. And down here at the bottom, what that was just showing is, in this case, they did like a confirmation pop-up dialog box. All right, so that's the eye chart for the back, if you can read the top line there. But this is showing the typical BeEF user interface. So whoever's running BeEF and they're hooking the clients, you log into a web-based interface. On the left-hand side, it'll show you who are the clients that are currently online and who are the ones that we know about, but they're currently offline because they may come back. Now, what's interesting there in that concept is, wait a minute, how do you know if they come back? And that's because BeEF uses, if you remember, ever cookies came out a while ago, right? Makes it very, very hard to get rid of these cookie values because they're not just stored in the browser. If you go in the browser and say, oh, delete all cookie cache stuff, that's not the only place. It does it in like flash storage. It puts it all over your system. So if the user ever comes back to your website, it'll check in with BeEF again and say, yep, I'm back. Okay? So this is the typical user interface. You can click around, and there's all sorts of cool stuff that BeEF can do. We don't need to cover all of this stuff. OK, so the quick background, right? Had to give you the cliff notes enough to understand the concept of what we're talking about. So let's focus in now on making the dashboard. All right, so we have a couple different components. The first one, again, we start with ModSecurity. ModSecurity would be a web server module inside either Apache, IIS, or also Nginx. That's what we're working on right now. That's beta level. But it's in your web server platform. So what you can do is set up certain rules to monitor for certain activity. Now, what we're talking about here, what I'm going to demonstrate, it's not your typical, oh, I saw SQL injection, let's do something. There's different ways and times that you would want to do this. Because like I said, oftentimes, one type of an attack is not necessarily done by somebody in a browser. You want to narrow your scope to say, if somebody's in a browser, let's try and hook them. So you need to figure that out first. There's different ways in ModSecurity to do that. Once ModSecurity sees, oh, they've triggered whatever this logic is, now we're going to send down the code to do the initial hooking. Once they've done that, they talk with the BeEF server. So we're going to set up the BeEF server where we manipulate a few things to make it for our purpose. And then we have the audit console integration that we're going to talk about at the end, which is including WAF events into your console so you get a more context of what this user is doing. Right? So a couple different updates that I wanted to make. And this is when I was talking with Michele, saying, hey, if a defender's using this in production and they want to monitor bad guys, let's change, essentially I said, let's skin it. Give me a whole different user interface. I'm not looking at hooked browsers, zombies, all of that kind of stuff. I'm interested in online attackers, monitored attackers, things like that. So that's a simple text change. So there's some modification you can do there as well, just to skin it more for your preference. You can also disable certain features, and we'll talk about that, certain things you probably do not want to have activated in production, specifically integrations with Metasploit and all sorts of other types of browser exploits, those types of things. But then also up here at the top, bless you, the initial hook. Okay, there's a telltale sign because it's called hook.js, that if you have an attacker and they're monitoring certain things that are happening, they may see something related to BeEF, something related to hooking, that's going to send up a red flag. So there is some sort of anonymization you want to do, make it more benign. So that was an easy change. You can go in the config file and say, okay, instead of calling this hook.js, let's call it image-min.js, something that wouldn't raise a flag. Okay, so there's certain customizations. Tailor it for your use case. Okay, so looking here, this was a quick screenshot. Now, I will say if you're looking closely on the rest of the screenshots for the rest of the prezo, you'll see some differences because I took screenshots at different time in development, so certain text has changed. So, but looking here, on the left-hand side, you can see now we have monitored attackers, online attackers, offline attackers. And then on the right-hand side, you have that tab saying current attacker. So once you select somebody, that screen will come up, and then you can dig in a little deeper. All right, so BeEF hooking, defender style, right? So we don't have to look for cross-site scripting. That's the advantage that we have. We control the output. We control the response. All the data going to the client, we can change it at any time that we want. Okay, so this is the reference that I made before to AppSensor. So this is a project I also contribute to. And there's a certain section here talking about alteration of honey trap data. So taking a step back, what we're talking about, honey trap. Now, how is that different than a honey pot? Right? Typically, honey pot systems are totally separate servers or applications, VMs. They're totally separate systems that you would redirect traffic to. The difference between that and a honey trap is the user is actually accessing and interacting with your actual web application. We want to alter some of the HTML and things going back to the client and seed it with deception points and traps, saying, okay, if somebody messes with this, we know you're up to no good because a regular user would never mess with this. What's nice about that is essentially zero false positives. If somebody messes with this, they're up to no good, then you can take certain actions against them. Okay? So there's all sorts of cool information. If you want to read more about AppSensor, we have a couple different detection points related to this. If somebody is accessing a certain resource or altering data, we'll show you some examples here. Okay, so setting the honey traps. Why did I use ModSecurity for this? ModSecurity has some pretty cool data manipulation capabilities. So I'm showing you some different directives, operators, variables. So show of hands real quick. Who has ever written a ModSecurity rule? Just so I know who I'm talking to. Okay. All right, so some of this stuff, once you get into looking at rules, if you want to start playing with this is all going to make sense. We have our reference manual, so you can read up on this to know exactly what this directive does. But essentially, you turn this on, and then for our purposes, when outbound data is leaving, we can change whatever we want. That's the bottom line. Now, what's cool about this is we're doing this transparently to the web application. They're sending data out. We manipulated it onto the client. When it comes back, we can even take it back out. So that you don't have to change the application code. That's why this is cool. So you don't have to get developers involved. They don't have to maintain the code. This is something you're integrating into your defensive infrastructure. All right, so here's some examples. Right, where to start? Honey traps. It's like, ooh, all right, what can we do? So you need to figure out where are some good detection points if somebody's trying to enumerate, footprint your web application and find those injection points or weak points. What do they typically do? And that's why I find it fascinating, and I love my day job, working at Spider Labs, because what do you think I did? I talked with the app pen test guys, right? And we can collaborate and talk about this and say, when you're getting ready to hack into a site. What do? Oh, I do this first. I'm like, okay, I'll set a trap there. Cool. And so we have this back and forth, figuring out where to seed these things. So this is just a small example, just to get you started. So one thing to talk about is robots.txt. Okay? If you know what robots.txt is for, right? You put that in your document root. That's purpose is to tell search engine spiders, crawlers, where they're allowed to go on your site and where you don't want them to go on your site. So if you see a big flaw in this is, number one, there's no access control. You're just listing, I don't want you to go and index this directory called admin.back, customer records. You're basically telling the bad guys where there's sensitive data on your site. So malicious users always go here, they'll look at it and say, I'll take this, I'll start putting this into Burp Suite, so I can start enumerating there, brute forcing directory stuff. So that's a good place to start. So the idea is, on the fly, as you're sending robots.txt file back out, manipulate that and add in some fake directories that you know about. Those are some honey trap detection points. The next one is HTML comments. Attackers will typically look through the source code on your pages, and a lot of the tools they use will flag that and say, hey, there's HTML comment here, you might want to look at it. Now, why is that a problem? Yes?
Does ModSec actually allow you to edit the response body too?
Yeah, okay, good question to make sure. Yes, we can alter and modify the response body going out. Okay? So HTML comments, you've probably heard the horror stories. When stuff is going through development, QA, staging, and it makes it into production, oftentimes in dev and staging, they're doing certain debug testing with QA tools and whatnot. You'll find all sorts of interesting HTML comment code. Oh, if you want to get debug output, toggle this bit. Add a parameter called debug on. And then all of a sudden, the application acts differently and it sends out code. When it gets promoted to production, somebody forgets to strip that data out. Bad guys will see that and say, now I have a new thing that I'm going to check on. Okay, next one, fake cookies. That's a really good one. To put some information in a totally fake cookie that means nothing to the application, but it may entice the attacker to say, oh, wait a minute. There's a cookie called user role. It's numeric, 1. What if I change that to 0? Do I become an admin level? You know, do I change the context in the application? So you just set that. Now, in this case, ModSecurity is not the one setting that directly. We don't handle setting cookies. But what you do is you set information in an Apache environment variable, and then in Apache mod headers will go ahead and add that for you. But we know what data we want to add to a header, or in this case, a cookie. And then when that cookie value comes back in this case, if user role is never equal to 1, if it's ever anything else, we know somebody has manipulated that cookie. And the last one, which we're actually going to dig into here a little bit deeper, is fake hidden form fields. Okay, so hidden form fields, assuming most of you know what this is, in case you don't, the HTML that comes down, there's certain characteristics in there where the code is telling the browser, this is data that we're going to send back in a form. Don't show this to the user. This is stuff that the application needs for tracking purposes, but the user doesn't need to change it. They don't need to interact with it. It's going to confuse the user, so they're hidden, right? So, I mean, it has a legitimate purpose. The problem is when you actually start using that for sensitive tracking and changing things on the server side, you hear all the horror stories before of shopping carts putting the price in a hidden field, and people buy stuff for 99 cents, all that kind of stuff. So we know bad guys look at this, though. They look at hidden fields. They'll manipulate hidden fields. So let's put a fake hidden field in there. So that's what we're showing here. So again, ModSecurity rule. So for those of you who've never worked with ModSecurity rule, this is a general syntax here for you. Starting with sec rule, you're defining a rule. The next argument is the variable. What data do we want to look at? So in this case, actually answering your question back here, if we want to manipulate the live outbound data, it's the stream output body. So that gives us access. We can change what we want and then swap it back in, and Apache sends it. Okay, after that, we get into the operator that we're using. So now we have access to this response body going out. So in this sense, think HTML. What do we want to look for? So we have this operator up here called rsub. You define an operator by doing the @ symbol and then rsub. So we're doing a regex substitution. Right? So if you're familiar with any other type of scripting and stuff, or sed, same type of syntax, right? S/, look for this string, and you have another /, substitute this string. So what we're doing here is we're looking in the HTML for the HTML closing form tag. If we see a closing form tag, we want to inject something right before it. a new hidden parameter. Okay? So in this case, what we're doing is we're putting in a new hidden parameter called, what is it, admin equals false. Okay, something maybe enticing. So how would this look to the user, right? If it's a regular user using a web browser, they wouldn't see it. It means nothing. Nothing happens. Now, if you've ever used, from a pen testing perspective, this is kind of a cool plugin called Ground Speed for Firefox. It's a little different than using something like Burp Proxy or Zap or something like that, where here it ties in, kind of peels back the layer. It ties it to the user interface, so you have a better idea of what it is tied to. So for example, if you intercept something in Burp Proxy and you see a certain parameter field, you're not really sure in the UI what that was. You lose context when you access that away from the browser. So what this is showing here is in the login form, you have admin hidden, and then down there at the bottom, they even highlight it for you. So the user doesn't see this, but if you're a bad guy, you would see that and say, oh, okay, user admin equals false. Let's change it to true, right? Let's see what happens. So this is what ModSecurity would see. Right? If we set the previous rule where we're going to put this fake data in, we need to have other rules that will look to see if it's ever manipulated for our honey trap. So down at the bottom, you can see this user sends it in, and now admin equals true. They've altered it. Okay? So now we have our rule up here at the top. All we're looking for is if the argument admin is ever not equal to false, that's a problem. So when you see that, what do you want to do? Do you want to block? In this case, no, we're not blocking based on that. What we're doing behind the scenes is we're setting another variable. In this case, we're flagging this person, this transaction, as a malicious user. So we have malicious client equals 1. Then we have the helper rule down here at the bottom. This is where we do the BeEF hooking, where we say if for a certain request coming in, ModSecurity says this is a malicious user, we're going to hook them. So some other cool features here. We're doing rsub again. And in this case, we're taking the closing HTML tag, and then we're hooking it. So it's basically at the bottom of the page. We're just adding in some JavaScript there. It's going to go to the BeEF interface, grab that hook. All right, so once they are hooked, now we get them in our UI. So we have our Defender dashboard. We get a new, let's say, malicious user up here, 172.16.67. Now you can see, excuse me, once you click on them, the Details tab, it's pretty cool when you think about it, the insight that you're getting into this end user now. Now in this case, it's general information about their browser. Different plugins, what version do they have? Do they have WebSockets? Do they have Java enabled? Interesting things that maybe you would want to use later on. All right, so executing BeEF commands. Now we've hooked them. We have the capability to execute different commands. What do we want to do? So this is where I have to stop, timeout. Ryan, you got 2 left. Okay, caution. Okay, because we had a lot of interesting conversations internally about once you have this level of access, what should you do? What can you do? What should you not do? I'm not going to tell you that. That's for you to talk to your legal department on if you're ever going to deploy something like this and figure out where do you draw the line? What are you using this for? What we're focusing on for this proof of concept is monitoring and enumeration. That's it. No exploits. We're not hacking back. We're not doing anything like that. So now that that is covered, so we're focusing on the monitoring capabilities. So from my perspective, what's really cool, because this has been a big frustration of mine, is looking on the graphic on the right-hand side, something like Tor. If somebody's going to manually attack your site, right, they're not going to do it from their home system and go directly to your site, right, or they're not going to be hacking very long. So what's interesting here is if you look at that graphic, if you assume here that Alice is attacking in a browser, and here we have our setup with ModSecurity and BeEF, that hook and that code is going to traverse all the way back through Tor until it gets into their browser. So once you've hooked them, now you get that insight and we can do certain things. But still, you want to know, I would want to know, if anybody's doing anything with law enforcement, trying to go and arrest people doing this kind of stuff, addressing the threat rather than the attack, you got to know geographically, where are these people? Okay? So a couple different things I would suggest that we have talked about, something you maybe would want to play with. The first thing is persistence. When BeEF does its initial hook, it's only monitoring the current page that they're on. If they traverse to a different page, they're gone, and they would show up in here as offline. So I would suggest immediately, if you hook somebody you want to track, you go to a certain module here called persistence, and it does, I forget the actual technique that they're using there, but it's essentially, they call it man in the browser, right? So it's making sure that when they traverse around your domain, they are still hooked. Okay, next one, getting the geographical location. There's a lot of different modules to do this. There's also different things that BeEF will tell you based on a color coding system. On certain things, will they even work against this browser because it knows what type of browser they're running. Also, certain things that you may choose to do may alert the malicious user that you're doing something. They may get a pop-up if you try and run a Java applet. Okay, so choose this carefully. But I'm thinking, what are some things that would be useful to a defender for traceback and trying to take care of the threat? So getting physical location, there is an option here, excuse me, under host called get physical location. So what's cool looking here is on the right-hand side. You can probably see it if you're up closer, but for this particular thing, it was checking local Wi-Fi networks. And a lot of times, by the way that those are named, or if they've registered and Google knows about the Wi-Fi, right, from doing the Wi-Fi driving, they can tell, oh, you're close to this Wi-Fi. We know that's in Fairfax, Virginia. That's giving you a general location of where this person is. That may be useful, right? iframe event logger, keystroke logging. That may be pretty cool as well. Instead of just looking at the final web request that comes to your site, maybe it's an attack, maybe it's not, this will actually send down, excuse me, an overlay with an iframe and does event logging. So as they're typing anything that's on your domain, it will actually send it back to you. So you can see it. So here's an example. Looking here on the far right side, it says the command results. So you can see in this case, this was me playing around with it, but doing like cross-site scripting, SQL injection, whatever it is, you're gaining some insight, though, into what they're doing locally versus what they're ending up sending. That may be useful, right, to try and track this, figure out motivations and intentions. All right, the last piece, this is kind of very hot off the presses. We were working on this as of last week. I have been using, from a WAF perspective, the ModSecurity Audit console. It's free, it's open source. It's essentially a Java app web interface where, go here, you take ModSecurity, it's creating these audit logs. You can send it across the network to a central logging host if you wish, or you can run this locally on your system. But this is built from the ground up to handle ModSecurity's audit log format. But it's great because you can imagine if you have to look at just log files and figure out what the heck is going on, it's not very conducive, right, to time-sensitive issues. You need to have a better way to manage this stuff. So I had already been using this. We'll show you an example here of some of the screen interfaces. So this is typical, though, of what you'll see with most web defensive dashboards. And that, again, is looking at individual requests, looking at connection. This connection was bad. This request was bad. It's useful information. It just wasn't enough. So I'm trying to combine all of this together. My hope is, and actually in talking with Christian Bockerman, he's the developer of the Audit console, great guy, added in. He's got some other cool API features, and talking with Michele. And BeEF, which also has an API, we had interesting discussions of, no, I have an API. You grab data from me. No, I have an API. So we got to figure out how to integrate. I could foresee extending the Audit console, so we have a different dashboard tab that essentially would just bring in the BeEF UI. So you don't have to go to all these different dashboards. But looking here, some different capabilities based on the transactions. Yes, you can search by IP, but again, that wasn't enough. But as I said, there's an API here, so we said let's leverage this just for the proof of concept here for the AppSecUSA. So essentially what we're having is the BeEF UI. It's going to make a RESTful API call to the Audit console, pass certain information about the client, and say, do you have any WAF events that ModSecurity saw, other stuff that this person was doing, give them to me so I can show them to the user. So this is some newer stuff. I don't even think it's pushed out in the BeEF code yet, but you'll be able to go into a config file and set this up. If you want to integrate BeEF with the ModSecurity console, you just set certain features here and they will talk. So looking here, we have a new tab, right? So in BeEF, if you're looking at the current attacker, we have a new tab on the right called WAF events. That's where it makes the API call, grabs that data, showing them to the user. They can kind of see, okay, yes, we hooked this person. What are they up to? Okay, it's looking like they're doing some SQL injection. There's like app leakage stuff, technical information. Then you can click on any one of these individual events if you want to see more data. Here it's looking at the actual ModSecurity rules that triggered for a specific transaction. So you can see very specifically what they were trying to do. And since you have all the audit data, this is also the response data that was leaving your web application that went back to the attacker. That may be useful to see also. All right, I saw the warning sign go up. So I think this is good because I want to leave time for questions here at the end. A couple different points. Down at the bottom, specifically, tomorrow, the open source showcase, I think it's upstairs, 17th floor. I'm going to be up there with ModSecurity, so anything ModSecurity related or this, if you have other questions, you want to demo stuff, whatever, come see me there. Feedback, let me know. OWASP emails, work emails. Other than that, let's open it up for questions. Yeah. Yes, and actually we were just talking. I'm going to be giving this to the coordinators, and I know it will be available through OWASP for the conference. So yes, everybody will get access to the slides.
So are you suggesting doing this on production systems or just honeypots, honey traps, whatever you want to call them?
I think it would be, that's actually a good question. I think it would be useful in production, but I definitely see how you could integrate, for example, I have other examples that I use. Once you tag a malicious user coming to your website, instead of initially hooking them directly, you can set up specific proxying only for that user. So they're actually going to the website they think to, but on the back end, you're proxying them off to a totally separate honeypot system. So I think there is some integration you could do with separate honeypots versus production. But the point is you want to identify people that are attacking your production websites. So however you can do that, yeah.
So, I mean, isn't it going to, if you do it in a production system, isn't it going to severely cripple your performance because you're now rewriting all your responses to include these potential interesting tidbits for the attacker?
I think it depends on where and how and when you want to lay your honey traps. You may want to pick certain locations, right? And I was showing the basic, like you said, any form anywhere, just seed it. That's a good point from performance perspective. That you may want to pick login pages, admin functions. Pick and choose certain sensitive areas where maybe you want to target and only do it there. I think it does bring up an interesting concept. Like I think everybody can agree, all right, there's some interesting value here that we should evaluate if, when, and how to use it. And yet, there needs to be some lines that will be different for each organization on how they would want to use this, what would they want to do. You hear the term before, like poking the bear. I also use messing with Sasquatch, right? If you want to get into a fight, you all know how those commercials end. So be wary of when and how you want to use this. But I personally am a little bit sick and tired of playing whack-a-mole and trying to figure out some way to enumerate where these people are, not so I can compromise their system, but so we can try and address the threat. Yeah?
And none of this really actually requires ModSecurity. That's just your example, sort of.
Exactly. Proof of concept, that's the tool I had that could do the job. But exactly, if you have a different mechanism for putting this in your application through different means, narrowing the scope of how effective this is, they got to have a browser that can execute the code. So that's a whole range of things that we can't address when it's just these headless scripts. But yeah, if they're very, very paranoid in how they're setting up their browsing experience, and if they can figure out making sure nothing persists, maybe you can't track them beyond an initial attack session. True. Yep. Good. All right. Thank you, everybody.